Hey guys, welcome back to the QST YouTube channel. Today we will be solving the term 2 week 7 AMS quiz. Let's go. Consider the forces acting on a triangular lamina that can rotate about the vertex A. Which of these forces will produce a turning effect on the lamina? Okay. So for this question, we know that all of the forces that are like in the same line as A, like here or here, don't have a turning force. So F1, neither F1 nor F4 have a turning force. So it's only F5, F2 and F3. Number 2. A force F is applied to a plank that can rotate about fulcrum A, as shown in the diagram below. Look, to know if like the moment is out of the plane of the picture or inside the plane of the picture, we're gonna have to use the right hand rule, which is by first of all we need to find the pivot, which they gave as A. Determine the position vector. Okay, so we're gonna have to like okay, so we're gonna have to put our hand, like our right hand, on the force. Okay, I mean on the fulcrum or the pivot. So then we should curl our fingers, like the rest of the fingers, towards the direction of the force F. Like not upwards, like towards F. And then and then it will show that your thumb will be directed like out of the plane of the picture, or like onto your tablets or computers or whatever, or outside, like right outside. Okay, to find like the moment, we know that counterclockwise is positive. Let's say we have a phone. Okay, you have your phone with you. Exert a force are like approximately around the same place as they're exerting a force F. You'll notice that like the the object that you're putting the force on is moving counterclockwise. So you'll know that it's positive. Drag and drop the equation that relates the moment of a force F to the arm of movement D. Okay. So for this one, we're gonna have to memorize the rule M equals F, which is the force, times the perpendicular distance from the pivot. Number 4. Consider a horizontal force 20 newtons to the vertex of C of a rectangular frame. The moment of F about a vertex A is... Okay, so for this question, let's draw the arm of moment. Wait. So like this. Okay. Now the perpendicular distance from A to F is gonna be this distance, because this is perpendicular to it. Actually, no. It's gonna be CD, because look, here they want like, as we said in the previous question, like to find the moment we need to do the force times the perpendicular distance. The perpendicular distance is AB, which is 60 centimeters, which we're gonna have to convert to meters. So 12 times, I mean 20 times 0.6, which will give us 12. Okay, number 5. Consider two forces, each of a magnitude 15 newtons, applied to a twist 2 centimeter. Okay, so for this question, it's really simple. All we're gonna have to do is like any force, both like either one of the 15s. So 15 times 2 centimeters, which is 0.02, which will give us 0.3. 15 times 0.02, which is 0.3. Number 6. The quantitative measure of the turning effect of a force is called the torque. This one we're gonna have to memorize it. Okay, it's either called the torque or moment of a force. Number 7. In which direction should he apply the force? Okay, a mechanic is using a spanner to loosen a bolt as shown below. In which direction should he apply the force generated by his hand in order to produce a maximum torque on the bolt? Okay, so as we know from like the start of the chapter, we know that the ways we can turn like anything so we can get the most torque is by making it perpendicular, like perpendicular to the point of action. So the direction, let's say, let me draw a seesaw, let's say. The most force, like, how can I, or let's give an example of a doorknob. Okay, so the most, like, so we can apply the maximum torque, we just need to apply a direction perpendicular to the pivot. Number 8. The magnitude of the moment of the force acting on the body is 4 newtons per meter. Okay, let me. Okay, so for this question, we have the pivot 0.2 meters and 20 meters. Okay, as we said before, moment is equal to force times perpendicular distance. Okay, 20 times 0.2. Now to know if it's positive or negative, we can use a pencil, a pen, anything. Okay, we can just put our finger, like two of our fingers on top of each other, like on like an approximate position of the pivot. Then we just put a force on like estimated, like as we can see here, it's they're acting a force here. So we're just gonna like approximately uh, like put a force on it, and we'll know that it's turning counterclockwise, which here they say is positive. Okay, as we said, since it's counterclockwise, it's positive, and the body is rotating in the positive sense of rotation, meaning that the moment is positive, which is, as I said before, is because it's counterclockwise. Select the picture that represents forces forming a couple. Look, a couple of forces is like, okay, is two forces in opposite directions acting on different parts of the object, but they're gonna give the same amount of torque. So yeah, so that's it. A force of 40, the force F of 40 newton, of magnitude 40 newton, is exerted on a square lamina of sides 2 meter. This creates a moment of negative 40 Newton per meter. Okay, so as I said before, okay, as I said before, so the ones that are like attached, like P and Q, okay, just let me get to the drawing up, like P and Q have a torque of 0. Now why doesn't it say R here? They said that the force creates a moment of negative 40, which means that the force is moving counterclockwise like this. Okay, so which one of these forces will act counterclockwise? T, like as I said before, use your phone, pen, pencil, eraser, anything. And if you do the exact same thing, you'll get that T makes it go counterclockwise. And S also makes it go counterclockwise. Okay, number 11. The net moment of these fours, okay. ABCD is a rectangle of sides 10 and 12 centimeter as shown below. Okay, so ABCD is a rectangle of sides 10 centimeter and 12 centimeter as shown below. Three forces are applied to its sides. Force 1, which is 8 newtons and is applied vertically upward at the midpoint of BC. Force B2, force, I mean, force F2, which is 10 newtons and which is applied at C along the diagonal AC, and force 3, which is 4 newtons, applied rightwards of the midpoint of CD. The net moment of these forces is blank. Okay, let's get to this. So, as we said, F1 is 8. Okay, F2 is 10, and F3 is 4. Okay, so first of all, we need to like find the moment. So let's say F1. Let's take F1. Okay. They said they wanted it about A, the pivot A. So, what is the perpendicular distance between, like, from A to F1? It's gonna be this. Okay. Which, as they said, is the midpoint. So, we have 6 times 8. But, we're gonna have to find out if the force is positive or negative. And since, as I said before, clockwise means that if the torque is moving clockwise means that the moment is negative. But if it's moving counterclockwise, it means that the torque is positive. Okay, so as I said, we can use a pen, pencil, whatever, to find out that it's negative. 6 times negative 8 is equal to negative 48. So that's the torque of A done, of F2 done. Now let's find the of F1 done. Let's find the torque of F2. My bad guys, I made a mistake by by using a wrong shape because I used my phone in a like horizontal way. So it turns out that the torque of F1 is 6 times 8, not negative 8. Okay? Which means we'll get 48. So for F2, we notice that the arm of moment is attached to A, meaning that F2 won't make the rectangle turn. Okay. F3, which has a magnitude of 4 newtons, and okay, so as we said, this part is 5 because they said here it's the midpoint. And here we said, as we said before, F3 is 4. So they gave us the perpendicular distance and the force. So now 5 times. To find out if it's 4 or negative 4, as I said, just take your phone or tablet or whatever and just take A as the vertex because they say they want it here, and we do like act as if you're pushing a force on like that part of the rectangle, phone, object, whatever. Anyway, you'll find out that it will turn like clockwise, which which as I've said many times before, clockwise means that the force is negative, so we have negative 20. Now here they want the net moment. As we said, F1 plus F2 plus F3 is equal to F net. I'm calling F as like the torque. Okay, so negative 48, I mean just 48 minus 28 minus 20 plus 0, which will give us 28. Consider the forces F1 and F2 that act on the plank which can rotate on the triangular fulcrum. Drag and drop the correct answers to complete the sentences below. As I've said for a previous question, for questions like these, we're gonna have to use the right hand rule by putting our hands on the fulcrum, curling our fingers towards the force, and then our like no, not index finger, our thumb will like indicate if it's into the plane, outside of the plane. Okay. And as I've said before, like, let's say we have a seesaw. Okay. Let's say we have a seesaw like this. Here. Let me draw it here. And let's say you're pushing it up. Won't that make this turn clockwise? Okay. And as I've said before, like if the object turns clockwise, means that it is negative. Okay. Let's do the same thing for F2. So let's say we're pushing a force like this. It will turn the seesaw counterclockwise. So that means that it will be like the torque will be positive. Number 13. A person pushing a box a person is pushing a box across the horizontal floor. The box gets stuck at the door stopper as shown in the diagram below. Which of the forces acting on the box will produce a clockwise moment to it? Okay, so let's see. Let me draw the force. Okay, go on. So the force is weight. Okay, so like let's say the pivot that we have here is the door stopper, and weight is pushing the object down. So try doing this with a phone or a pen or anything, and you'll realize that it's moving clockwise. And then, as I've said before and many times, and I'll continue saying it, because like whenever it's clockwise, the torque will be negative. That's it. 14. In the diagram below, F1 is equal to 50, F2 is equal to 20, F3 is equal to 60, AB is equal to 10, BC is equal to 2, and AD is equal to 6, BD is equal to 8. ABD is the right triangle. The moment of F1 about A. So this is F1 and this is A. As we can see here, F1 is attached to A. So that means that the torque is 0. The torque of F2 about A. So this is F2 and this is A. So the perpendicular distance between F2 and A will be AD, right? Okay, so we have F2 is 20, okay? And as we said, the perpendicular distance is 6. But we're gonna have to find out if it's positive or negative by using any object and acting as if the force is acting on it, and you'll find out that it's moving clockwise. So it's negative 20 times 6, which is equal to negative 120. The torque of F3 about A is, so this is F3 and this is A. As we can see, the perpendicular distance is AC and F3 is 6. So let's do, so it is 6 times 12. And again, we're gonna have to find out if the torque is negative or positive. We're just gonna act push the object upwards like this. Like, let's say this is your object. You're gonna move it like this. It's gonna move like this, of course. Okay, so we have 72 as the torque of F3. The net torque is just that we add everything together. Everything we found from part A to C. So all we're gonna do is negative 120 plus 72, which will give us negative 48. Number 15. Okay. A spool has an interior radius of 10 centimeters and an outer radius of 15 centimeters. A couple of forces, each of magnitude 200 Newton, is applied to the outer radius of the spool as shown in the diagram below. Two or more forces equal in magnitude F are applied to the inner radius, okay, so that the net moment is 0. Okay, so the magnitude of the moment created by the, wait, what? The spool has an inner radius of 10 centimeters and has an outer radius of 15 centimeters. A couple of forces, each of magnitude 200, is applied to the outer radius of the spool and is shown in the diagram below. Two more forces of equal magnitude F are applied to the inner radius. Okay, so the magnitude of the moment created by the forces, as you can see, as I've said in like in the first or second question, these two forces are couples. Okay, are like couple forces. So as we said, the big circle's radius is 15. So this is 15, and this is 30. Wait, what? Yeah. Okay. So this is 15, and this is another 15. Together that's 30. And as I've said before, couple forces is 200, the magnitude times the distance between them, which is 30 centimeters. But since they want it in meters, 0.3, which will give us 60. The force exerted on A must be leftwards because uh, why should so for like the reason why the force F exerted on A must be to the left is so this one so this and this cancel out. Okay, and the same thing goes for B, like this. Then these two will okay, will cancel out. Part C. The magnitude of F is what is blank. So we have in the magnitude of the moment, since they said the net moment is 0. Okay, so 60 times, I mean 60 is equal to, as we said before, that they're asking for F, which is like the inner, and as we said, AB is 20 or 0.2 meters. So 0.2 times F. So F is equal to 300. Thank you guys so much for watching this video. Hope this video guys helped you guys so much. Good luck in your exam. Goodbye.